Today we're going to be talking about adding and subtracting mixed numbers. Adding and subtracting mixed numbers is very similar to adding and subtracting fractions, except now we have whole numbers and fractions. However, you have been working on adding small fractions, so adding and subtracting mixed numbers should be no problem for you. Okay, let's take a look at the first example. First of all, it's always good to do an estimate. For the purpose of this video, I won't be doing estimates for all of my problems because the video will get a little bit too lengthy. However, it is a good idea to always estimate. Take a look at the first one. If you look at 2 and 2/7, we know that 2/7 is less than a half because half of 7 is 3 1/2. So this is less than 2 1/2. So this piece is actually less than 1/2. So 2 plus 5 is 7. This is a half. This is less than a half. So this half and this fraction, which is less than a half, are not going to equal a whole. So since 2 plus 5 is 7, these two pieces are not going to equal one whole. So we know our answer is going to be approximately less than 8. Okay, let's go ahead and talk about this. First of all, I am requiring that you stack your add-ins when you are adding mixed numbers. So even though it's written horizontally, please write them in this format so I can nicely see your equivalent mixed numbers. Okay, watch how I copy the whole number. I want you to copy the whole number so you don't forget he's there. But actually what we need to do is the whole numbers are fine to be added as is. You've been adding 5 plus 2 for many years now in school. It's the fractional pieces. Right now our fractional pieces have different denominators, and you know how to make them equivalent. So you're going to do the exact same process that you've done with small fractions, and you're going to find a common denominator, preferably the least common denominator. So in this case, the LCD, or the least common denominator, of 7 and 2 is 14. So I'm going to rewrite my equivalent fraction. I'm going to multiply by 2 halves. So this becomes 4/14. Now this is 2 wholes and 2/7. Now I've rewritten it as 2 wholes and 4/14. Same thing for this. I need to multiply by 7/7 to get that as a 14 on the bottom. So now it used to be 5 1/2. Now it's 5 7/14. When adding mixed numbers, now the only thing you have to do now is just add the fractions like you've always been doing. So we know that 7 plus 4 is 11. Copy the denominator. And now the only added step is we have whole numbers to add. 5 plus 2 is 7. Always make sure you're in simplest form or lowest terms. In this case, the only factor 11 and 14 have in common is 1, so we are in simplest form. The final answer is 7 11/14. Take a look at the second problem. 7 1/6 plus 2 8/9. Once again, I rewrite my problem so that I have room to find my equivalent mixed numbers. 7 1/6 plus 2 8/9. I'm going to rewrite my whole numbers, find my common denominator, which the least common denominator in this case is 18. And then I'm going to rewrite my equivalent mixed numbers. Multiply by 2 to get 18, so I multiply the 8 by 2. Technically, I'm multiplying by 2 halves, which is equal to 1 whole, and this becomes 2 16/18. Multiply the 6 by 3 to get 18, so I multiply 1 by 3 to get 3. And again, I'm really multiplying by 3/3, which is 1 whole. So now I have 7 3/8 plus 2 16/18. I add my numerators like we have been doing. 3 plus 16 is 19. Copy the denominator of 18. 7 plus 2 is 9. Now, when we go to the simplifying step this time, we notice that there's something interesting going on. 9 wholes and 19/18. Well, 19/18 is an improper fraction. So simplifying 19/18 would mean turning this into a mixed number. But we already have 9 wholes here. So watch this. I'm going to copy my 9 wholes. Now 19/18, I'm going to decompose it. 19/18 is really 18/18 plus 1 more 18th. So I have 9 wholes, and then I also have 18/18 and 1 more 18th. That's what I have right here when I'm saying the answer is 9 and 19/18. It's really the same as saying the answer is 9 with 18/18 and 1 more 18th. This is the decomposition of 19/18. Well, I know that 18/18 is equal to 1 whole. So 9 plus 1 whole is actually equal to 10. And then I have this 1/18 left over. And since 1/18 is simplified, that's my final answer of 10 1/18. So that's the only time when adding mixed numbers becomes slightly complicated, when your two fractional pieces add together to equal more than one whole. In the first example, these fractional pieces equaled less than one whole, and I didn't have to do that. However, in this example, 3/18 plus 16/18 equals 19/18. Well, 19/18 is the same as one whole plus 1/18. So our answer used to be 9 and a fraction. Well, this fraction is actually equal to one whole, so that's why our answer became 10. And then the leftover fractional piece was 1/18. Okay, let's take a look at subtraction. In the case of subtraction, you're doing the exact same thing, except you're going to subtract the numerators. So again, I'm going to rewrite them. 8 2/3 minus 2 3/9. Find your equivalent mixed numbers. Notice I recopy the whole numbers so that I don't forget they're there. In this case, the lowest common denominator is 9. I'm skipping through finding that because you guys have worked so hard already on that. In this case, to find my equivalent mixed number, all I have to do is multiply by 1/1. So 2 3/9 didn't change at all. Here, this guy became 8 6/9. Again, equivalent mixed numbers. Now, you can't forget this is a subtraction problem. So instead of adding the numerators like we did before, we're going to subtract. 6 minus 3 is 3. Copy the 9. 3/9 is the fractional answer. 8 minus 2 is 6. So my answer is 6 3/9. However, that's not simplified, so I'm going to simplify it by dividing by the greatest common factor, which is 3. So my answer, and I copy the whole number again, because the whole number did not change. All that changed is I gave a new name to 3/9 by dividing it by 3/3. 3 divided by 3 is 1. 9 divided by 3 is 3. So my final answer, in simplest form, is 6 1/3. So the only difference is, this time, since it was a subtraction problem, I subtracted the numerators and subtracted the whole numbers. Okay, let's take a look at this subtraction problem. First of all, I want to talk estimation on this one for a minute. If you take a look, the problem is 10 3/5 minus 5 3/4. Well, first of all, I know that 3/4 as a fraction is larger than 3/5. They have the same numerator, so I'm talking about the same number of parts. However, the size of the parts are different. These parts are larger. So I have 3/4. The smaller denominator is actually the larger fraction when the numerators are the same. So this piece is larger than this piece. So even though 10 is larger than 5, and that's fine, when I go to subtract my fractional pieces, I'm going to be taking away something bigger than what I have. So let's watch how that works. 10 3/5, rewriting it, minus 5 3/4. Common denominator, copy your whole numbers, find your common denominator, which is 20, lowest common denominator. Rewrite your equivalent mixed numbers, multiply by 5/5, this becomes 15 20ths. Multiply by 4/4, this becomes 12 20ths. And here's where we see the problem. We know this is a subtraction problem, so we have to do 12 minus 15. Since the fractional piece on top is smaller than what we need to subtract, we're going to have to borrow from the 10. So what I do is, just like in whole numbers, whenever your bottom number is larger in the ones place than your top number, you had to go over and borrow from the tens place and bring one group of 10 over. It's very similar, except for this time we're taking away from the 10, we're borrowing one whole. So it becomes a 9. Well, when we borrow that one whole, we're going to call that one whole 20 20ths. 20 20ths is equal to one whole. So when I went over to the 10, I regrouped it or borrowed from it. I crossed off the 10, called it a 9, and then that one whole that I borrowed, instead of calling it one whole, I called it 20 20ths, which is equivalent to one whole. Plus, I can't forget that I already have 12 20ths as part of the original problem. So 9 20 20ths equals 10. I did not change the value of that 10 at all. I just called it by a different name. Plus, I had the 12 20ths as part of the original problem. So this whole thing over here equals 9 32 20ths. Now the bottom number, I don't have to change at all, so I usually just write him over again so he's nice and lined up with the new subtraction symbol so that you don't forget you're subtracting. and I just move this number over so that he's lined up. Now, let me say that again. When I borrowed from the 10, I called it a 9 and 20/20ths. 20/20ths is equal to 1. So this 10 and this 9 and 20/20ths are the exact same thing. This right here is equal to 10. Plus, I had the 12/20ths, that was part of the original problem, and this whole thing equals 9 and 32/20ths. Now I have enough to be able to subtract. I can do 32 minus 15, which equals 17. 12 minus 5 is 7. 2 minus 1 is 1. And then I copy my denominator. Now I need to subtract 9 minus 5 now. 9 minus 5 is 4. That is simplified. So your answer is 4 and 17/20ths. Again, I had to borrow one whole from the whole number in order to make my fractional piece large enough to be able to subtract 15/20ths from it. Let's look at one more example with subtraction. What happens when you have no fractional piece? 14 minus 2 7/10. A common mistake is that kids would just write the 7/10 down here and then go ahead and subtract the whole numbers. However, you can't do that. You need to take 7/10 from something, and there's no fractional part here at all. So you borrow from the 14, call it a 13, and then this time I'm going to look ahead and know that I need to subtract 7/10. So that one whole that I borrowed, I'm going to call it 10/10. So again, 13 and 10/10 is equal to 14. So I didn't change this number at all. I'm going to recopy the bottom number, 2 and 7/10, and now I can subtract. 10/10 minus 7/10 is 3/10. 13 minus 2 is 11. And I look, and my final answer is already here because 3/10, 3 and 10 have no common factor except for 1, so I'm in simplest form. So once again, in this case, I had 7/10, but you can't subtract 7/10 from nothing, even though there was no fractional part here to be able to subtract this from. So I had to regroup or borrow. 13 and 10/10 is equal to 14. That allows me to be able to subtract something here, 10/10 minus 7/10 equaling 3/10, and then 13 minus 2 is 11. Now you have been shown how to add and subtract mixed numbers. Now you're going to try. Good luck!